So let's talk about the newer API for fine-tuning. It's called fine-tuning as opposed to fine-tunes. And as of the end of August 2023, this just came out. This is a big deal because it allows you to fine-tune the newest models from OpenAI like GPT 3.5 and coming soon GPT-4. Works in very much a similar way to the older API, but the difference is that the input data is in the chat completions API format. So whereas you're still providing a JSON-L file for training that contains one line of JSON in each line, there's a little bit more structure in that data now. So you can see an example of that to the right here. Let's say we want to make a fine-tuned model of GPT 3.5 that can play the role of Data from the TV series Star Trek: The Next Generation. Data is a fictitious android, and we're going to try to make a real artificial intelligence out of a fictitious one here. So it's kind of fun, right? So in this case, we can actually give a system role with each message if we want to, where we can provide some of that extra context about what we're trying to do here. Here I'm telling the system, I want you to be Data, and Data is an android from that TV show. And then we can provide examples of the user and assistant responses there. And we could actually do, larger conversations here if we wanted to train it even more. If we had sort of a back and forth going on between two characters, we could put the whole thing in there. But in this case, I'm just going to use individual pairs of lines of dialogue here where somebody says something to Data and Data responds to it. So for example, from the very first line Data had in Star Trek in Season 1, Picard says, "You will agree, Data, that Starfleet's instructions are difficult," to which Data said, "Difficult? How so? Simply solve the mystery of Farpoint Station." You're so optimistic, Data. And like we said, the power of this is that this is where the new models can be fine-tuned. So if you want to be training the latest and greatest stuff, this is the API for it. Now, they are adamant in the documentation to make sure that you are making sure that you really need to fine-tune these things because these models are really good out of the box, right? So oftentimes you don't need to fine-tune it to get the results you want. Sometimes it's just a little bit of finessing your prompts, a little bit of prompt engineering, and that can get you where you want to be. Or just putting in a handful of examples in that conversation to go off of as opposed to doing a more expensive and heavy-handed fine-tuning operation. So OpenAI really wants you to make sure that you need to do fine-tuning before you go down that path. Using the older API with the older models, there was a lot more incentive to do fine-tuning, but these newer models sometimes don't really need it. And in fact, if you ask GPT 3.5 to play the role of Data from Star Trek, it does a decent job out of the box. It will do a better job after this fine-tuning, but it does raise the question of how it got trained on copyrighted TV scripts, doesn't it? Once you have that fine-tuned model, you're going to be using it with the Chat Completions API as opposed to the Legacy Completions API, as would be expected. It's pretty easy to use, though. Again, you just say, here's this messages structure, just like we have on the right, but we're going to leave the assistant role off and allow it to generate that for us. And also something that's kind of neat is you can provide both training and validation files to this fine-tuning job. You use OpenAI's File API to upload those ahead of time, and then you'll refer to them by their IDs in the subsequent requests to create that fine-tuning job. This gives you some actual metrics on how well it's doing on creating the responses in that validation file. So it's not entirely a subjective measurement anymore. You can actually get some numbers around how well it's doing and predicting what Data would have really said. So let's dive into an example and actually make Data for real, a real AI based on a fictitious AI using OpenAI. Okay, so for fun, we're going to use the new OpenAI fine-tuning API to fine-tune GPT 3.5 and create our own real AI version of Data from Star Trek based on the fictitious Data from Star Trek. So we're making a real AI based on a fictitious AI. What a time to be alive, right? So to do this, we're going to train GPT 3.5 using every line of dialogue Data ever said in the TV series Star Trek: The Next Generation. And that should produce a simulation of Data that's pretty darn close to the original. Now, where am I going to get this data from? So I can't give you the scripts of Star Trek. That would be a copyright thing, although Star Trek is pretty permissive with this stuff. They actually have guidelines for fan films and whatnot. But if you search online for Star Trek scripts, they're pretty easy to find. For example, we can go here and find every script of Star Trek: The Next Generation. Let's start with their very first episode from the very first season. If we scroll down a little bit here, we can see that one of the first scenes is actually Picard talking to Data. And Picard says, "You will agree, Data, that Starfleet's instructions are difficult." Data says, "Difficult? How so? Simply solve the mystery of Farpoint Station." You're so optimistic, Data. So our challenge here is to create a training data file that we can use to fine-tune GPT 3.5. So the approach I'm going to take is to extract every line that Data ever said and take the line before that. So these are going to be the conversations that I'm going to train it with. So for example, I could say the system role is that I'm an android on Star Trek: The Next Generation, And then the user will be whoever's talking to Data. So that would be Picard saying blah, and then the assistant will be Data. So Data will say difficult, how so? And if I do this for everything Data ever said, I should be able to use the chat completions API to actually get responses from my simulated data going forward that are consistent with how Data spoke in the actual show. So we need to write a script to do that first. And if you do have access to the course materials that are part of this larger course this video is from, you'll have a copy of that. Let's see if I can bring that up here. So that's going to be called extract script new.py. Let's take a quick look at what's going on here. This isn't terribly relevant to OpenAI, but it's just a pre-processing Python script that I wrote. And data wrangling is a big part of the job, right? So what we're going to do is kick things off down at the bottom here with process_directory, and I'm going to point that to wherever I stored all of the scripts that I downloaded from that site that I just showed you. So those are all tucked away there, and if you're doing the same thing, you'll have to change that to wherever you save them as well. It's also taking in the character name that I'm interested in. So I could actually simulate any character in Star Trek using this same technique. But for me, I'm going to stick with Data just because it's so poetic to simulate a real AI with a fake AI or vice versa, whatever it is, right? So what does that do? Process directory. Pretty simple. We just iterate through everything in that directory path. We get the full path to each file that's in there, which represents a script. And then if we confirm that that's a file and not a directory, we'll then pass that file into extract character lines. And that's where things get a little bit more dicey. So scripts are not exactly structured data. So we have to make some assumptions about how to process information out of them. So we're going to go and open up that entire script and load up every individual line into an array here called lines. And what I need to do is keep track of whether or not the current line that I'm reading in is part of a line of dialogue. So if we take a look at what one of these scripts look like again, where is that? We can see that the problem here is that every line could be part of a larger line of dialogue. So a quote-unquote line of dialogue can actually span many lines. How do I know whose is whose? So the assumption I'm going to make is that if I see a line that just has one word and it's all caps and it doesn't have a number in it because that might be referring to a line number, that's going to be indicating that a character is about to say something. So if I see one word in caps, Picard, I know the following lines are going to be something that Picard said. And when I hit a blank line, I'm going to say, well, okay, that indicates that he's done saying whatever he was saying. So what this script has to do is figure out who's saying what by looking for these single lines with one word that is all caps. Keep track of who's saying that. If it is the person we're interested in, Data, I'm going to refer back to the previous line that I saw. And after that first line of a character name, I will keep on reading lines of information and stick them all together into one line until I hit a new line, and I'll associate that concatenated line of dialogue with that character. And we do that over and over and over again every time that we see Data say something. That is fundamentally what this script is doing. So we have a little flag that keeps track of whether a character is speaking right now, whether we're in between a line with one big capitalized word that indicates a character name and a new line that came after it. We're also keeping track of the current character who's speaking. And as we go through, we're going to use this is single word all caps function, which is a little helper function that figures out whether or not, first of all, if this is one word, and if so, it doesn't have any line numbers embedded into it, so it's actually a character name. And if it is all in capitalization, then we will make an educated guess that this is in fact a character name about to say something. As we go through it, we'll open up the resulting output file here, which will be data_lines.jsonl. And for every line, we will write out the required format for the chat completions API, where for every line we have a messages structure, where we have a system role. And for this particular example, the system will always be Data is an android in the TV series Star Trek: The Next Generation. Technically, you don't need that, but it does provide GPT 3.5 with a little bit of extra context about what you're doing. We then provide the user role, which is the person who is talking to Data, the assistant role, which is whatever Data said in response. And we do that over and over and over again. Finally, we need to create train and evaluation files out of this. So we can actually give OpenAI both a training data set and an evaluation data set to measure its progress as it goes. So as it's training or doing this fine tuning, it can check its results against what Data actually said to stuff it hadn't seen before and see how close it's getting to how Data really would have spoken. And that gives us some actual metrics and numbers we can use to say, yeah, this is actually doing a good job of simulating Data as opposed to just going with subjective judgments, right? So we call this little split file function here to do that. Our original Data file was that data_lines.jsonl file. We're going to split that off into a data train and a data eval file with a default 80% split of train and test data. And if you do want to truncate that to save money, you can set max lines to something smaller. So while I was developing, I just restricted myself to 100 lines of dialogue to make things go a little bit faster and make sure it didn't cost me a lot of money while I was working out the kinks in this thing. But there's about 6,000 total lines of dialogue in the resulting data file, so we're going to up that to 10,000 to make sure that I train it on the whole thing in this example. All right, so we can actually kick that off and create the files that we want here. All I have to do is say python extract-script-new.py, and assuming that everything's in the right place, it will go off and generate those training and test files. So let's see what we got in here. Or star.jsonl, we can see that we have the data lines.jsonl file, and then the eval and train 80-20 split there that we created as well for actually using and fine-tuning the model. Now to actually do something with this, I'm going to go and open up a notebook. So if you are following along, if you have an Anaconda prompt, you can just type in Jupyter Notebook to launch one. I already did. So let's go and take a look at what that looks like. So again, in your course materials, if you are following along as part of the larger course, there's a Making Data Python notebook here, so you can go ahead and open that up. Do not follow along, however, unless you're willing to spend money. This is going to cost, probably around $50 in training costs. So if you're not willing to invest that much in making your own data, just watch, okay? First thing we need to do is make sure that we have the latest version of the OpenAI package installed. And I've already done all this, so I'm just going to kind of walk through it all here instead of actually incurring those costs again, right? That will go off and install that if you need to. You need at least version 27.9 to get the new fine-tuning API. After that, we import the OS and OpenAI packages that we need, and we set the API key to my OpenAI developer key, my secret key that I got when I created my API account. That is currently stored in my system and variable called OpenAI_API_key, so I don't need to show it to you. But you do need a valid developer key to actually use this. Once that's done, though, we don't need to refer to it again. It makes it pretty easy to use. First thing we need to do is upload the training and evaluation data files that we created from that script that we just saw. So we use the File API to create a new file that we upload to OpenAI. We give it the path to that file, and we say that the purpose is fine-tune. That's important so it can actually use it for fine-tuning. We do the same thing for our evaluation file. And you can see that it's giving us back, among other things, the IDs of these files after they're uploaded. So we need those IDs in subsequent requests to the API. First thing you're going to want to do is check the status of those files. So if there was some sort of validation error, if the JSON wasn't well formed, this is where it would tell you about it. We can just say file.retrieve, pasting in that ID that we got back for the file to get the status of what that file actually is. So in this case, I'm checking that evaluation file and making sure that it says everything's fine. If it didn't, it would say, no, there's an error. You have malformed JSON, and here's where the actual error is, and help you to fix that. OpenAI says they're going to be putting out a Python script to help you validate this data before you get to this stage and actually give you an estimate of the training costs as well. As of this recording, that has not been released yet, but probably will be by the time you watch this. Now that we have our training data and evaluation data in place, we can just go off and start our fine-tuning job. And to do that, we're going to pass in the ID of our training file that we uploaded through the File API, the validation file. And the validation file is optional, by the way. You don't need to provide that. And also the name of the model that we want to fine-tune. In this case, GPT 3.5-Turbo. So yeah, we're actually fine-tuning GPT itself. And coming soon, they say GPT-4 can be fine-tuned as well in the same way. So this is exciting stuff. We're taking the latest and greatest AI technology and making it even more specific and fine-tuned to our needs. In this case, making data from Star Trek. Once that's done, it will give us back some information about that job. And if we want to keep an eye on it, this does take some time. In my case, it took about a half an hour, which is pretty darn good, really. We can use the fine-tuning job.retrieve function using that ID that it gave us back again as part of that response to the create call. And that will give us some general information about the fine-tuning job just to make sure that it's actually going off. For example, it's saying that the default number of epochs was 3. I could specify that as part of the fine-tuning create command there too and specify a number of epochs that I want. You will be charged by the epoch by the number of tokens in your training data set, so do not increase that to more than you need would be my advice unless you want to pay for it. And if you want to keep track of what it's doing, you might remember from the older legacy fine-tuning API, it would periodically give you some textual updates. The way to get that through the API here is by saying list_events with a list of any events that you want to get status on and a limit as to how many of the most recent events you want to see for those particular jobs. So again, I'm passing in the ID of that fine-tuning job I just created, And by the time it was done, the last message I got was that the fine-tuning job successfully completed, hooray. And it also gave me the ID for that fine-tuned model, which I'm also going to need. So if I want to actually use this model to do something, like using the chat completions API or using it in the playground, I'm going to need that ID and use that to refer back to it. And we can see that when it was done, the training loss was 1.89 and the token accuracy was 0.54. This is a little weird. Like in previous experiments with this new API, it would give me repeated metrics as to how that training was going over time. In this case, it just gave me the one at the end. But usually you can see that going up and down as the training progresses, and you can get a sense as to whether or not it's actually getting better or not. All right, so let's actually use this thing. So to do that, we're going to use the chat completions API. And its format is very much the same format that we used to train it with. So the same data that we used to fine-tune it is going to be the same format that we used to consume this fine-tuned model. So just for comparison, let's take a look at how the non-fine-tuned model does with a specific query. Let's say I want to use the default GPT 3.5 Turbo model. And I'm going to say, hey, Data's an android in the TV series Star Trek Next Generation. Picard's saying, Mr. Data, scan for life forms. What should Data say? And I'm going to kick off this chat completion request and print out the first choice that it gives me back. In this case, it gives me a really wordy answer that probably isn't what Data would actually say on the bridge. I, Captain, scanning for life forms. However, as an android, I do not possess the biological sensors typically used for such scans. Instead, I rely on my advanced sensors. Blah, 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 blah. All right, a few problems here. It did a decent job of getting like how Data talks. You know, it says do not instead of don't. There's no contractions that Data uses. So it kind of has the gist of how Data speaks, but it's not really accurate to how he would talk in an actual episode of the TV series, right? First of all, this is way too wordy of a response that would be used in television. Second of all, it kind of assumes that they're standing on a planet somewhere and Picard's asking Data to do this scan himself instead of using the facilities of the ship, which again, wouldn't really happen. So it tried, but it's kind of off the mark. Let's see how our fine-tuned model does instead. So here we're going to say the model is not just GPT 3.5 Turbo. It's going to be GPT 3.5 Turbo 0613 colon my specific fine-tuning job ID here. And I'm going to give it the same exact query. And this time it says, I am finding very low levels of radioactivity. I cannot make a conclusive scan for life forms, Captain. Much more data-like, much more dramatic, much more like something you would actually see in the TV show. So that's pretty cool. We can also use the OpenAI Playground to play around with our fine-tuned model and play around with our real data based on fictitious data. Here I have one example I just did where I said, Mr. Data, get us out of here, warp 9. To which Data responded, the spatial rupture is collapsing faster than our ability to clear it, sir. So not only is that something Data might say, but it's creating some drama, you know, something you might actually see in the TV show, which is pretty cool. And you can play around with this and just add your own little stuff here to it. We'll take out the assistant role, change the user prompt to something else. I don't know. Let's say Picard. What else might he say to Data? I don't know. Mr. Data, how is your positronic matrix performing today? Actually, you know, Geordi would say that, wouldn't he? Nerding out a little bit here on you. And he wouldn't say Mr. Data, he'd say Data. So, all right, Data, how do you respond to that? For some reason, his performance is not satisfactory. The first officer claims that he would like to make certain I am operating efficiently. Again, you know, a very data-like response there. So it's, you know, gets to the point, and it's also implying some drama in that Commander Riker like sent him to see Geordi about a potential problem. So that makes a lot of sense. Let's do one more. Data, how is Spot doing? And if you're not familiar with Star Trek, Spot is Data's cat. Oh no, Spot's not doing good. Let's give it another shot. Spot is functioning within acceptable parameters. That's a little bit of a better data-like response. And since we do have the temperature at 1, it's going to have a little bit of randomness to what it says. Oh wow, okay, cool. And you can see here we're using our train model. If we were going to like go back and use the non-fine-tuned model, let's see what that does. So in this case, using the default model, we're getting again kind of a too wordy answer from Data here. Data is functioning normal. It is, you know, in the style of what Data would say, but a line of dialogue in Star Trek generally would not go for this long. And it's a little bit too much information. So, you know, again, we're doing a little bit better with our fine-tuned version, but the original one wasn't too bad. And again, OpenAI does make a point of saying, these new models are pretty good at pretty much everything, so make sure you really need to fine tune it before you go through all that expense and trouble. However, I do think mine is better. Let's switch back to my fine tune model. What else can we ask it? Let's throw it a trick question here. Let's say Troy wants to know how Data's feeling. I'm making this up as I go. Data, how are you feeling today? Trick question, because Data doesn't have feelings unless it's later when he has an emotion chip, right? Oh gosh, I'm getting nerdy. Oh, that's a pretty good response from Data. I'm functioning within normal parameters. I recently completed a series of complex calculations. So he's not talking about emotions because he doesn't have any. He's just saying, well, I'm operating as I should. So I think that's what you were asking, right? Let's do it again. Ah, an even better one. Feeling. Do you mean, how is my emulation of human characteristics progressing? A very Data-like answer. So that's it, guys. We have actually created our own version of Data from Star Trek, a real AI based on a fictional AI. And that's pretty darn cool. Anyway, that's the new API for fine-tuning, GPT 3.5 and soon GPT 4 from OpenAI in action. So have some fun with that and make cool stuff. Thank you for watching. If you found this video helpful, please hit the like button and subscribe to our channel, and check out the course linked to in the description. Thanks for watching.